Hey guys, so before I jump into this video, I just want to say thank you so much for the support that you guys have been showing lately. I don't know if it was just from that MOSFET video, but it is incredible the amount of comments, the subscribers, and the views that I've been getting recently. Never in a million years did I think that so many people would be interested in these videos, and just thank you. That's really all that I can say. I'm going to try to be consistent with videos, but when I get busy, it's hard to. So I'll keep doing them. They're just not going to be consistent, most likely. So the first video back, it's going to be a update to the panelizing video I did a while ago. There's been quite a few changes in the way we do them for when we panelize a board through KiCad. And in the last video, I didn't include the panelizing library, which I know a lot of people were asking for. So the library will be in the description. I'm just going to, I think, link it to a page on our website rather than GitHub, because that's kind of where all of our work files will be. And I'd like to keep those separate for now. So for the test board, it's just like a 30 by 35 millimeter rectangle with some passives just to kind of show off a few things. So the first big thing that is different now with the new way we panelize is we'll actually put the tabs in on the bare board itself on the board design side, because it makes it a lot easier to decide where the tabs will go, and you don't have to kind of pick and choose from the panel side, and it just makes it a lot cleaner. So just as a recap, the panels that we almost always do are mouse bite or routed tabs. So the blue you see, I use the comments user layer. Obviously doesn't matter as long as it's not one that's used for anything else. And that represents a 2 millimeter router that the fab house will cut around the board. And then where they don't cut, you have this line of drill holes, which when you bend the board, they will snap off and leave you a clean edge along the length of the board. And this is in comparison to a V-score, which is along the entire board. They're nice because you don't get that little jagged edge at the tab, but they're super inaccurate how big and small the edge will be, and you wouldn't be able to really do it on this board because these passives are too close to the edge, and you have to follow the guidelines along the entire length. Where a tab, as long as you don't have components near where that tab is, doesn't matter. And they have a lot more support, because a V-score, it's flexible along the entire length, where the tab, it's a solid, rigid piece where that tab is. So first thing we'll do is just throw on the tabs on the edge of the board from how I said in the last video. So you want to keep from any edge, you don't want to have an edge unsupported for more than like 10 or 15 millimeters, which this is a narrow enough board, we should only need one. So we'll take this one and then move it over here, and we could either put it on this side or on this side. Want to try to mirror left and right and top and bottom just to make it easier to deep panelize. It's not required, but it makes it a little awkward to deep panelize if you don't. So this is more than 15 millimeters, but on such a small and light board, I don't think it'll be an issue. A lot of this is kind of just experience with doing it a decent bit, and honestly, guess and check. If you do one and it's too flimsy or it's hard to deep panelize, you want to make changes for the next time you do it, obviously. But on a small board like most people will have, as long as you have one tab roughly center on each board, that should be fine. So here's 4 tabs, and if we fill in our copper, since I have a keep out around each drill hole, it makes sure that if any component is within that, you're gonna get a DRC error, and it's gonna show you which part you have to move, which is obviously really nice. Now I'll fill in the rest of the comments layer, which again is our 2 millimeter router. I think I went too far, nope. So yeah, sometimes you have to worry about going too far and cutting over where your tab is, but as long as you go to where it is magnetic, you shouldn't really have to worry about that. So now this is our board file done, and notice I used the drawings layer for the edge. You don't want to use your edge cut because the edge cut is going to be on the panel outline, not on the individual board. So if you want to export this as a step file, you're going to have to go in and change the drawing layer, the drawing edge, to be a edge layer, but then just revert it back when you go to panelize it. So now we need to append this into PCB new, which a big change also is I'm using a nightly build of KiCad 6 because it allows you to move a board with a reference point, which is something that should have been in here from the get-go. I'm using a nightly from like October something, which they don't have up anymore, but any of the newer ones should work. Just make sure it's not one that has a bug, or they all have bugs. Make sure that PCB new still allows you to do this, and I would not suggest using nightlies for your normal designs, but just for panelizing, I've never seen an issue. So we'll go ahead and append the board. Again, now it's super nice. You can go to Special Tools and Move with Reference, and it lets you pick where your reference point is. So now we will move this to 0, 0 on the bottom left-hand corner. And for this board, since it's pretty small, I'm going to go ahead and do a 4x2 panel with a 5mm gap per board, per where the router is, just to give the board a little more support so it doesn't bend. Most people will disagree with me on that, but since we have an assembly line, I really hate when boards are going in the reflow oven and they warp. So I would rather give up a little bit of real estate and pay a little more per panel than have the boards warp. That's, again, personal preference. Most people want to squeeze every board out of the panel size to save some money, but I think that comes back to bite you in the long run. So for our board, we want to do 4x2, and our horizontal spacing, we do 39 by 44. And let me make horizontal positive. So now it goes right to left. So now we have a 5mm gap here and a 5mm gap here, which again just gives us more fiberglass, so the boards and the panel will be that much less likely to warp. Now, if we were to take our edge layer and draw a box around here, that's all fine and dandy, but we can't depanelize this board right now, or this panel, because there's no way to actually break these boards out. So we have to add tabs that allow us to actually snap each board out. And these you always want to do perpendicular to the long side of the board, because it's going to go in the assembly line left to right, so you have the least amount of board unsupported. I know that's kind of hard to explain, but you'll see once all the panels are in, it makes a lot more sense, or at least it should make sense. So if we take one of our tabs, take it to this corner, the center of the board, and the top corner, and place them just like this, and now take the exact same ones but put them on this edge at the same point. So now we have them all set up for here, and we can do the exact same thing and create an array. So now that the tabs are extended, now when you go to break this, you basically start breaking down on the short edge of each side. So you break this edge, this, and this, and now you have individual like strips of the PCBs, and then you just have to break this center horizontal part and then your board's completely depanelized. So now we can shrink down the edge cuts down to, again, whatever you decide you want your margins on the PCB to be, or on the panel, and that will really depend on who you're using for fab and who you're using for assembly. They'll have design rules which they'll state how much of an edge they want on the front and on the rails down here, which is where the actual board will become depanelized, or where the panel will go on the conveyor rail. So now the last thing to do is to add fiducials to the panel, and I just realized I don't have any fiducials on the individual board, so you would of course need to have that so the pick and place knows where to place all the components. So now we can set our fiducials on 3 sides. Again, this totally depends on who you're using for fab and who you're using for assembly. So now the stencil printer and the pick and place can reference where the board is and know where everything goes. So now the last thing I will do is I'll import this into, we use Fab 3000, which is a Gerber DFM tool, and it'll visualize what the board actually looks like with the routed edge. And I think that'll better explain how this actually will work and how you depanelize it. Okay, so here's the panel now imported, so you can see now physically what this will look like. The key with good panel design, at least the way that I look at it, is, again, I really like to have a stiff panel, and I'll sacrifice squeezing out an extra board or saving a little money on the actual panel cost. So since the board will essentially be clamped in the pick and place in the oven on this edge and this edge, you want to have the majority of your supports running lengthwise to make it so it won't flex. So that's why you want these to run the whole length, and you can have the width get cut or have a small tab. So realistically looking at this, the tab here on the top edges and even the tab here, we could actually get rid of because it's not going to add any extra support and will just make it a little bit harder to depanelize. So what we could do is just get rid of all of these tabs and then just straighten it out, and all that'll do is just make these actual short sections which just pop off. But for the sake of showing this, I don't think it's a big issue since I don't think I'm gonna get this board made. So yeah, that's kind of the workflow that I've been using. Time-wise, it definitely is not the fastest thing in the world to do. KiCad's still very clunky with it. Biggest issue by far with KiCad still is if now I need to make a change on that bare board, I don't have a way to back reference through KiCad to update it, which is a huge shortcoming of it, and it's why it still isn't a fantastic tool for panelizing. You either have to completely recreate your panel or go through and, I was not expecting it to work like that, to go through and select the board itself and delete it and then re-add the new board in that array. Hopeful that in KiCad 6 or 7 they'll have back annotating from a appended board, and then it makes this really trivial to update it. So that pretty much covers the new way that I panelize boards. If you have any questions about this or suggestions for future videos, please let me know, and I will see you in the next video.